This is known as a so-called supernormal growth problem. This is the hardest one of all. This is the hardest part of this chapter. A company has been growing at a phenomenal rate of 40% per year because of unexpected high sales. You expect this trend to continue for another 5 years, after which the company's growth will fall to 10% per year. So maybe after 5 years, there will be other competitors that will start producing a similar product to yours, and so you will lose your market share and you will only be able to grow by 10% per year, right? So 40% per year is for the first 5 years. After that, it's only 10% per year. The required return is 12%. That's our discount rate. And we also know that the company has just paid a $5 million in total dividends to its shareholders. What is the total value of its stock? So we can kind of simplify it and think of maybe a $5 dividend per share, and the question asks us to find the price per share. It would be the same calculations, really. Okay, so to solve it, I would like to sort of fit what's given to what we did in the previous two problems. And if you follow, you'll realize how this problem is actually solved exactly the same way as everything we've done so far in this chapter. First, again, notice that we have two growth rates in dividends. 40% per year for the first 5 years. So it's like growth rate number 1, lowercase g underscore subscript 1. And then the second growth rate of dividends after 5 years, 10%. So it's like G2, lowercase g subscript 2. Okay? And graphically, the 40% growth rate applies to dividends for the first 5 years, and the 10%, the second constant growth in dividends, applies from that point on in perpetuity. Let me explain you how I would solve a problem like this. So I label these as my solutions, because on the next slide I will show you a completely different solution that the book offers. And you can compare them and see which one you like better. So let me start with my solutions. What we know is that the company has just paid a $5 dividend. So if you're buying a share of stock now, you're not going to get the $5 on your share anymore. So it's kind of sunk cost. It already happened. It's not going to go in your pocket. What will go in your pocket is everything in the future. So my solutions say that let's calculate the dividends for the first constant growth time period, right? So let's calculate dividends for years 1, 2, 3, 4, and 5. If we know that the dividend that has just been paid was $5 and it will increase by 40%, then we can calculate the dividend after 1 year, for example, using the financial calculator, where the dividend today is saved as the present value, 5, make it negative, PV. Then we want to find the dividend after 1 year, so 1 will be our N, and the dividend will grow by 40%. So 40 is our IY. And then you press compute and FV, right? That's how you would get $7. Then the same way, you can calculate the dividends for years 2, 3, 4, and 5. I've brought up all calculations already. Notice that I'm using exactly the same approach to find those other dividends. I'm using the most recently paid $5 dividend as PV for all dividends. I'm using the 40% growth rate throughout as my IY. I'm only changing the number for N. N equals 1, what we just did to find the first year's dividend. Then N equals 2, 3, 4, and 5 to find the dividends 2 years from today, 3 years from today, 4 years from today, and 5 years from today. And so now I have found the dividends for the first 5 years. $7 in 1 year, then $9.80, then $13.70, then $19.20, then $26.90. All of these are rounded, so it's a good idea to increase the decimal places, right? I'm only showing the answers rounded to the first decimal place. That's actually, to be honest, may not be good enough because I'm already rounding 1, 2, 3, 4 numbers, and I'm not even done with the problem. This is just one of actually 3 steps. But anyway, you can, increase the decimals and leave more numbers like 3, 4, 5, 6 for each dividend, and then complete the problem. Okay, now step 2. The 5th year dividend, $26.90, is the end of the first constant growth time period, but it's also the beginning of the second constant growth time period at 10%. So why don't we say that, okay, well, year 5 dividend, 26.9, is the first one in the growing perpetuity, right? So now we are fitting this problem to look like our previous 2 problems. So we have a growing perpetuity. Let's find its present value. Again, it will give us the answer 1 year before this dividend in year 5. So it will give us the present value 4 years from today, right? And the answer is, so you put in the numerator $26.90, and in the denominator you put 0.12 minus 0.1. 12 was a 12% discount rate, it was given. And 0.1 is the 10% constant growth rate in dividends after the 5th year, which is also given. So this entire increasing dividend sequence boils down to $1,344.56. And now, again, just like in my previous problems, let's see how we have just simplified the whole thing. It's as if we have $7 at the end of the first year, $9.80 at the end of the second year, $13.70 at the end of the third year. And then at the end of the 4th year, and it's the last one on our timeline, we have $19.20. And we also have the present value of that remaining growing perpetuity, $1,344.56. And there is nothing else on our timeline after year 4. Nothing. It's all blank. So we only have 4 cash flows of different amount on our timeline, right? And now, how would you find their present value in today's dollars? You can do one by one, or of course you can use the cash flow keys. So let me bring up the financial calculator. I'm gonna clear everything, second, plus, minus, enter, and start all over with the cash flow keys. Cash flow button. If you buy this share of stock, you don't get the dividend, any dividend right away. So there's nothing in year 0. And keep it at 0, press enter, and then press the down arrow key. Cash flow 01, it means what's the first future cash flow? That's $7 in 1 year. So you press 7, enter, down. What's the frequency of the first future cash flow? Meaning, how many times do we have it consecutively? Only once. In theory, we could have $7 again and maybe again. But here it's only once, and we keep the frequency at 1. We don't change it to anything. Let's press the down arrow key. Cash flow number 2 in the future, what is it? That's the second year dividend, 9.8. So you put 9.8, enter, down, and down again because it's only once. Third cash flow in the future, that's 13.7. 13.7, enter, down, and down again. Cash flow number 4 in the future. So you can combine these two numbers, the fourth year dividend and the present value of the growing perpetuity, which are happening in the same year, and just put the sum of $1,363.76. So I'm putting that $1,363.76. Enter, down, down again. There is no more cash flow 05 or cash flow 06 and so on. We are done. So now press the NPV button. Enter the discount rate, which is 12%, right? 12, enter, down, compute. $890.51. Actually, on my slide it says $890.52. The reason I'm off by 1 cent, although it's not too much, is because of the rounding. In my financial calculator, I put in the rounded dividend amounts and the rounded growing perpetuity present value. If I did not round all my answers to only 1 or just 2 decimal places and kept more numbers, I would have gotten a more accurate answer. But I guess I ended up being off by just 1 cent, so it's not a big deal. Okay, so again, it's a two-step problem. Well, actually, it's more than that. First, we manually calculate the dividends one at a time for the entire first constant growth time period. And the last one is where you stop. The last dividend that you found is also the first. You can look at it as being the first one in the second constant growth dividend time period. And so we use that last dividend as our cash flow in the formula that calculates the present value of a growing perpetuity in the numerator. So that is our next step. Our third step is sort of to simplify the whole thing, kind of put our results together on this simplified timeline where we combine that present value of a perpetuity answer with the dividend, like right before 1 year, preceding the last dividend we calculate, in the very first step, right? So year 4 dividend in this case, and the present value of this growing perpetuity. And then we use the cash flow keys. Okay, so you would not want to pay more than $890.52 to buy a share of stock, which pays, dividends that first grow by 40%, and they will start with $7, right? And after the 5th year, they will slow down and grow by only 10% indefinitely. So this is the maximum price you should be willing to pay for such stock. Okay, so these are again my solutions. Remember, I said this is how I would solve it. And now let me show you how the textbook solves it. The textbook says, look, for the first 5 years, we have a growing annuity. That is correct. That's one way to look at it. And the first dividend in this growing annuity is $7. We already calculated it earlier. So it uses the growing annuity present value formula. Maybe you recall this very complicated formula from chapter 6 where it was introduced. And I also mentioned that you cannot do something like this in the financial calculator using those special keys. You have to do it by hand. So it gives the present value of the first 5 dividends, which is $51.29. Then the textbook says, okay, after the 5th year, we have a growing perpetuity, but it kind of, did the switch not where I, uh, you know, kind of made the cut of my dividends. So it actually says that the growing perpetuity starts with the year 6 dividend. In my solutions, it would start with year 5. So this is how the book does it. And so it needs to first calculate the 6th year dividend. And it does that by calculating kind of two future values. It calculates the future value of most recently paid $5 dividend after 5 years, right? So times $5 times 1 plus 0.4, which is the 40% growth rate initially, to the 5th power. And then, because we need to go one extra year further in the future, we should then multiply it again by 1 plus 0.1, where 0.1 is now the slower growth rate, right, per year. And this gives 29.6. Actually, the same number we got, but we actually the same number. You know what? We didn't even calculate this. In my solutions, you don't even need this number. But okay, let's continue and see how the book completes the explanations of the solutions. So growing perpetuity, year 6 dividend is 29.6. This is what goes into the present value of this growing perpetuity formula. So 29.6 is then divided by 0.12 minus 0.1. And it gives the present value at the end of the 5th year, counting from today. $1,479.02. And then what the book does, it says, okay, we have kind of calculated two partial prices. The price you'd pay to get the first 5 dividends is $51.29, right? And then all remaining dividends are worth $1,479.02 5 years from today. So that large second number needs to be discounted back by 5 years. And we divide it by, open parenthesis, 1 plus the discount rate, 0.12, close parenthesis, power 5. And when you add the two sort of partial prices together, you get $890.52. So this is the price today in year 0. The price you should be willing to pay, but no more than that, to buy 1 share of stock today with these kind of expected future dividends. And then the book summarizes how the solutions would be done for something like this. It calls it a 2-stage growth model, where you first calculate, where you need to calculate the price today, P0, and the formula uses, some future price. And long story short, I don't know what you think, but in my personal opinion, I would use the first approach. So let me just go back, show it to you. I think it's easier to first one by one compute the first dividends that belong to the first growth rate time period. Yeah, essentially this whole solution involves more steps, but I think you don't have anything complicated like this growing annuity present value, which you can only do by hand. So I think there is an advantage to my version of solving this problem in that every single step can be done sort of, pretty easily. And also, the most important reason is we again use the cash flow keys as sort of the last big step, just like I used in my previous 2 problems. Or how many were there? I think there were like 4 or 5 problems already. So in every single problem that we are covering, in this chapter, we are using the cash flow keys. So I'm kind of trying to explain it, this way, that cash flow keys fit any type of problem on stock price calculations.